In order to graph a polynomial function, we're going to follow these steps. Number one, use the leading coefficient test to determine the end behavior of the polynomial. That's our first big indicator. Number two, determine the maximum number of zeros and turning points. Number three, determine the y-intercept by computing f of 0. Remember, this indicates that we have 0, comma, something. Okay, that'll tell us our y-intercept. 4, determine the zeros and their multiplicities. That'll tell us the behavior at each of those zeros. And then last, sketch the graph. So for our first example, we have graph the polynomial function with the information below. F of x equals negative x cubed minus 2x squared. Now, the first thing I want to do is fill in spot number 4, the zeros and the multiplicity, because we actually found this in a previous video. That would be x equals 0 and negative 2, and those had multiplicities of 2 and 1 respectively. All right, now for our end behavior, this is an odd degree. It has an odd degree, and it has a leading coefficient that is negative. So that tells us that this function rises to the left and falls to the right. Now, based off of our degree, because our degree is n equals 3, the maximum number of zeros we could have is 3, and the maximum number of turning points is 1 less than that, so 2. Next, we can find the y-intercept by calculating f of 0. That would be negative 0 cubed minus 2 0 squared, which would be 0. So our y-intercept is the point 0, 0. Now we can put this all together and sketch. I know that my zeros are 0 and negative 2. 0 and negative 2. My y-intercept is 0, 0, which I've already plotted. Now, I know that my end behavior tells me something here. My end behavior tells me that it's going to come from the right, or come from the left, and my function's going to not cross there because of our multiplicities. Oh, actually it will. That's a multiplicity of 1. Yes, I'm looking at them in the wrong direction. All right, that will cross at that point. And it will not hit anywhere else, but I know that it will come back up to 0, 0, which has a multiplicity of 2, so that it bounces or touches, so it will come back this way, and I know that it should be going down and to the right. And that's my sketch. Now, if I were to use a graphing calculator to check this, this may not be an accurate sketch. However, with certain features, it should match up. We should have the correct end behavior, the correct y-intercept, and zeros with the behavior at each of those zeros. Our next example is graph the polynomial function with the information given below. F of x equals negative x cubed plus 2x squared plus 4x minus 8. Now, because this has an odd degree with a negative leading coefficient, just like the last one, this will be rising to the left, falling to the right. And because my degree is 3, I can have at most 3 zeros. Maximum number of zeros is 3, and the maximum number of turning points is 2. Next, I can calculate f of 0 to find the y-intercept. If you notice, we will have negative 0 cubed plus 2 times 0 squared plus 4 times 0 minus 8. Those first 3 terms are all 0, so this is minus 8. So that our y-intercept is 0 minus 8. Now the zeros and their multiplicities, we've already found this in a previous slide. Our zeros are negative 2 and positive 2. And we're only looking for real zeros. All right, and our multiplicities are 1 and 2 respectively. So plotting those, we have negative 2, positive 2. Those are all of our x-intercepts. And our y-intercept of 0, negative 8. Now, putting that together with our end behavior, our function will be rising to the left At negative 2, our graph will cross. And then I know that it will pass through 0, negative 8. And it will have to come back up here to 2, 0. And that has a multiplicity of 2, which means that it is going to turn and fall to the right. And again, this graph may not be the best, but it covers all the bases. All right, let's look at our last example for this objective of graphing polynomial functions. Graph the polynomial function with the information below. F of x equals negative 1/2, parentheses, x plus 3, close parentheses, open parentheses, x minus 1, that quantity squared, times x plus 2 quantity. Well, this one is written in a different form. It's in a factored form, so we can actually tell the zeros very quickly. X plus 3, that factor, will be equal to 0 when x equals minus 3, with a multiplicity of 1. The second factor, x minus 1 squared, will be equal to 0 when x equals 1, and that has a multiplicity of 2 because of our exponent. And the last factor, x plus 2, tells us that x equals negative 2 is a 0 with a multiplicity of 1. Now, if you add those multiplicities, we get 4. So that means that n is equal to 4. So this has an even degree with a leading coefficient that is negative, so that this falls to the left and falls to the right. Now, based on that degree, our maximum number of zeros is 4. Our maximum number of turning points is 3. And then we need to find f of 0 for our y-intercept. That would be negative 1/2 times 0 plus 3, 0 minus 1 squared, and 0 plus 2 is our different factors. That would be negative 1/2 times 3, and that would be negative 1 squared, so that's positive 1, times 2. And that is equal to negative 3. So that our y-intercept is 0, negative 3. Now let's put all that information together and sketch this function. The y-intercept is 0, negative 3. We can go ahead and plot that. And we have x-intercepts at x equals negative 3, 1, and at negative 2. From there, we know the end behavior is falling to the left and right. So I know I'm going to have something like this. It's going to fall from that point negative 3, 0, going to the left. And because negative 3 has a multiplicity of 1, it will cross. Now, my function has to come back down to negative 2, which has a multiplicity of 1, so that it will cross there as well. I know that it will come down and hit at 0, negative 3, my y-intercept, and it needs to come back up to x equals 1, which has a multiplicity of 2, so that it will not cross, bounce the other direction, and that matches my end behavior.